Hey there farmers, tech enthusiasts, and curious minds. Welcome to today's video where we're diving into the fascinating world of agricultural drones. Picture this: vast fields being monitored not by farmers on tractors, but by buzzing drones soaring through the sky, collecting data, spraying crops, and revolutionizing the way we grow food. That's not science fiction. It's happening right now on farms across the globe. Drones have transformed from novelty gadgets to essential farming tools, helping farmers boost yields, save time, and make smarter decisions about their crops. In this comprehensive guide, we've split our content into two main parts to help you fully understand this agricultural revolution. In the first part, we'll explore the various types of drones currently available in the agriculture sector, highlighting specific brands and models that are making waves in the industry. We'll look at options from industry leaders like DJI Agriculture, Parrot, AgeEagle, and Yamaha. Then, in the second part, we'll dive into the specific roles and tasks these drones can perform, from crop mapping and soil analysis to precision spraying and livestock monitoring. By the end of this video, you'll have a clear picture of how drones are changing farming forever. Part 1. Types of agricultural drones. Multirotor drones. Let's start with the most common type, multirotor drones. These are the workhorses of agricultural monitoring, perfect for smaller farms and specific tasks. The DJI Agris T40 is leading the pack, capable of carrying up to 40 liters of liquid for spraying operations. What makes this drone special is its ability to cover about 40 acres per hour, while using 30% less pesticide than traditional methods thanks to its precision spraying technology. Another standout is the Parrot Bluegrass Fields, designed specifically for agriculture. This drone can cover up to 74 acres on a single battery charge and comes equipped with a multispectral camera that captures data across 4 different spectral bands, giving farmers incredible insights into plant health that the human eye simply can't see. For those on a tighter budget, the DJI Phantom 4 Multispectral offers professional-grade plant monitoring capabilities at a more accessible price point. It combines a 6-camera array with AI processing to deliver actionable insights about crop health and stress levels. FixedWing Drones. When it comes to covering large areas, fixed-wing drones are the champions. The SenseFly EB-XAG is a standout performer, capable of mapping an impressive 500 acres in a single flight. With flight times up to 90 minutes, it's perfect for large-scale operations where efficiency is key. AgeEagle's XT model has become a favorite among commercial farmers, offering thermal imaging capabilities that can detect irrigation issues and disease hotspots long before they become visible to the naked eye. This early detection can save entire harvests that might otherwise be lost. The Wingtro One is another game changer, combining the benefits of fixed-wing flight with vertical takeoff and landing capabilities. This means it can fly like a plane for efficiency, but land like a helicopter for safety, making it perfect for rugged terrain or areas with limited landing space. Hybrid VTOL drones. The newest category combines the best of both worlds. The Quantix Mapper from AeroVironment can take off vertically like a multirotor, but then transition to horizontal flight, allowing it to cover up to 400 acres per flight, while still being able to land in tight spaces. Its RGB and multispectral sensors collect high-resolution data that helps farmers make informed decisions. Specialized agricultural drones. For specific agricultural tasks, drones like the Yamaha Phaser RG2 are pushing boundaries. This helicopter-style drone can carry up to 70 pounds of liquid and has been used for precision agriculture in Japan for over 2 decades. It's perfect for spraying operations in challenging terrain like rice paddies or vineyards on steep hillsides. The DJI Agris T30 is another specialized option, featuring a 30-liter spray tank and capable of treating up to 40 acres per hour. Its 8 rotors and advanced obstacle avoidance systems make it ideal for navigating complex field environments. Part 2. Roles and tasks of agricultural drones. Crop mapping and monitoring. One of the most valuable uses of drones is creating detailed crop maps. Using specialized cameras, drones can capture high-resolution images that reveal crop health, growth patterns, and potential problem areas. The Normalized Difference Vegetation Index, NDVI, captured by these drones helps farmers identify stressed plants weeks before problems become visible to the human eye. By flying the same route every week, farmers can create time-lapse maps that show how their crops are developing throughout the growing season. This consistent monitoring helps spot issues early, whether it's pest infestations, fungal diseases, or nutrient deficiencies. The data collected isn't just pretty pictures, it's actionable information that helps farmers make better decisions about when and where to apply resources. Precision spraying. Gone are the days of blanket spraying entire fields with pesticides or fertilizers. Agricultural spray drones can target specific areas with pinpoint accuracy, reducing chemical usage by up to 30% while still effectively treating crops. The DJI Agris series, for example, uses terrain awareness systems to maintain a consistent height above crops, ensuring application even on uneven ground. This precision approach not only saves money on expensive chemicals, but also reduces environmental impact by minimizing runoff. For organic farmers, drones can even be used to deploy beneficial insects exactly where they're needed most, providing a chemical-free pest control solution. Soil analysis. Before seeds even go into the ground, drones can help analyze soil conditions. By using specialized sensors, they can create detailed maps showing soil moisture levels, temperature variations, and even nutrient content across fields. This information helps farmers make informed decisions about what to plant where or which areas might need additional amendments. The 3D mapping capabilities of modern drones also help with drainage planning, allowing farmers to identify low spots where water might collect and damage crops. This kind of proactive planning can prevent crop loss and improve overall field health. Planting and seeding. Some specialized drone systems are now capable of planting seeds directly. Companies like Drone Seed have developed drones that can fire seed pods into the ground at specific locations, achieving planting rates of up to 40,000 seeds per day. While this technology is still emerging in traditional agriculture, it's already being used successfully in reforestation efforts and could soon become more widespread in farming. Irrigation management. Water management is a critical concern for farmers everywhere, and drones are providing new solutions. Thermal cameras mounted on drones can detect temperature variations in fields that indicate irrigation problems, whether it's overwatering, leaks in irrigation systems, or areas not getting enough moisture. By identifying these issues early, farmers can make adjustments before crops suffer, saving both water and yields. Some advanced systems can even be integrated with automated irrigation controls, creating a feedback loop that optimizes water usage based on real-time field conditions. Livestock monitoring. It's not just crops that benefit from drone technology. Ranchers and livestock farmers are using drones to monitor herds, count animals, and check on remote pastures without disturbing the animals. The aerial perspective helps spot animals that might be sick or injured, and thermal cameras can even find animals that might be hidden in brush or woodland areas. As we've seen throughout this video, agricultural drones have evolved from experimental technology to essential farming tools. Whether you're running a small organic farm or managing thousands of acres of commercial crops, there's a drone solution that can help you farm smarter, not harder. The combination of aerial imagery, advanced sensors, and data analysis is giving farmers unprecedented insights into their operations, helping them reduce costs, increase yields, and minimize environmental impact. As drone technology continues to advance and become more affordable, we can expect to see even more innovations in this space. If you're a farmer considering adding drones to your operation, start small with a mapping drone to gather basic crop data. Then expand into more specialized applications as you see the benefits. The initial investment might seem significant, but the return in terms of saved resources and improved yields can quickly make up for it. Thanks for watching our guide to agricultural drones. If you found this information helpful, please like and subscribe for more content on agricultural technology and innovation. Drop a comment below if you have any questions or if you're already using drones on your farm. We'd love to hear about your experience.